Hello, I'm Papri Ghosh. I'm from Computer Science Engineering Data Science Department of Haldia Institute of Technology. Today we are going to study about automata theory, and the particular question is DFA. You can say finite automata. So what is automata? What is automata theory? Automata theory is the theoretical branch of computer science and mathematics. Here we are going to study about the abstract machine, about the behavior of dynamic machines, and how to develop that machines, and how to solve the computational problem. So what is abstract machine? So abstract machines that we know the black box view. There are some inputs and outputs. So when we are going to map input to output, that is called function, and we are going to analysis or develop this function. So here that machine is called automata or automaton. Automaton is a singular form and automata is the plural form. So here an automaton is defined as a system where energy, materials and information are transmitted and used for performing some functions without direct participation of man. That means it's automatic. Used for performing some function, that means what is function? Functions means it's a mapping process where we are going to convert input to output. So we are going to study about automatic machines. So in finite, what is finite automata? So finite automata is a model that as a set of states, and its control moves from one state to another state in response to external inputs. That means, so in automata, when we are going to represent it, we are going to use certain pictures like this. Okay. So when we are going to represent any state, we are going to use circle form. Circle form means state, and this type of arrow is called transition. That means by this transition, we are going to move from one state to another state, and this transition can be possible using some input symbol. So here, when we are using that kind of picture, that means it's a initial state, and when we are using two circles, that means final state. Okay. So finite. So when we are going to represent a circuit with incoming edge, that is called initial state. We are going to represent the final state by using double circle, and we are going to use transition by using an arrow. So finite automata can be broadly classified into two types. One is finite automata without output, other one is finite automata with output. So today we are going to learn finite automata with output. There are three types: deterministic finite automata, non-deterministic finite automata, and non-deterministic finite automata with shadow. And finite automata with output is two types. One is full machine and another one is mini machine. So our deterministic finite automata has five levels: Q, sigma, delta, S, and F. What is Q? Q means finite and non-empty set of states. Sigma means finite non-empty set of input alphabet. Delta means transition function, and S means initial state, also set of initial state, and F is set of final state. which is a subset of Q. So here we are denoting that 0 less than equals to mod F less than equals to A. What is the meaning of mod F? Mod means the cardinality of the set F. What is the set F? Set F means set of final states. So what is the meaning of it? 0 less than equals to 0 less than equals to mod F less than equals to N. So that means the number of element in the set F can be 0 or less than 0 and can be equal to N or less than N. So what is the not less than 0, can be the number of element in the final set can be 0 and greater than 0 and maximum upper bound will be N. So what is the meaning of it? Meaning of it, that means the number of state in the final set can be 0. That means we can draw any transition diagram or any DFA that has no final state. It can be possible. Or maximum it will be N. So Q is the finite non-empty set of states and F is the subset of Q. Also, S is the set of initial states. Okay, set of initial states. Also, S and F is also the subset of Q and F is also subset of Q. Okay. And what is delta? Delta is a transition function. That means Q into that means if we apply any input symbol from sigma on any state of Q, then we are going to move a state that belongs to Q. Okay. So we have seen in our previous picture that is the initial state. If we apply A, so that is 1, 2 and 3. Okay. So here S means the set of initial state. The set of initial state is equal to 1 and F equal to 2. The state 2 is final state and Q equal to Q equal to 1, 2, 3. The total set of this picture. Total states of this picture. Here we have used 1, 2, 3. So Q equal to 1, 2, 3. So a set of initial state is S equal to 1 and set of final state equal to 2. So if we take 1 from Q and what is sigma? What is the value of sigma? Here sigma equal to A comma B. So if we have taken 1 and we have applied a symbol, input symbol from sigma like A. So we have applied A on A. If we have applied A on A, we are going to 2, and 2 belongs to the set of Q. So that is the transition function. So if we apply any input symbol on any set of Q, then we are going to a state that belongs to Q. That is the meaning of transition function. So S is the initial state and A is the set of final state. Now, so first we have to know two things. So that is called automata. And when any that means any string. What is string? First we have to know what is string. Wait. So we all know about what is string. So string is the collection of input alphabet. So when any automata is going to take a string, and if accepting that string, it will when we are going to apply that string on initial state and accepting that string. What is the meaning of acceptance of a string? If we have applied a string on inputs on our initial state, and if applying the input alphabet of that string, we can reach to the final state. That means that string is accepted by the automata. Okay. So take an example. Q0 A. QF is the final state and Q1. So that is our finite automata, and we are going to give a string. Now we are going to apply this string on this automata, finite automata. First, we are going to scan this string from left to right. So first we are going to apply A. If we apply A on Q0, it will reach on QF. Then again we are going to apply B on QF. So it will stay on QF. Then again we are going to apply B. It will stay on QF. Again we are going to apply B. It will stay on QF. Then we are going to apply A. That means again it will stay on QF. That means this string is final string because we have applied this string on our initial state and we have reached on our final state. So that is valid string. And what is invalid string? Invalid string is so BA. So first we are going to apply B on Q0, it will reach on Q1. Then we are going to apply A on Q1, it will stay on Q1. Again we are applying B, it will stay on Q1. Again we are applying A to stay on Q1. But applying this string on initial state, we can't reach to final state. That means this string is invalid. Okay? So now this string, we are going to store this string in this input tag. That is called input tag. And each square containing a single symbol from the input alphabet. That means if we when we are going to A, B, B, A, that means here will stay A, B, B, A. So like A, B, 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 A. So so the end square of the tail contain the end marker at the left end and the right end marker. So this is called left end marker and this is called right end. Okay. Now reading head. What is the function of reading head? The head examines only one square at a time and will move one square to the right. So at a time it will read one symbol and then it will move to the right. And what is the finite control? That is the main finite. Is that clear? Now we are going to produces a unique computation of the automata for each input stream. Deterministic refers to the uniqueness of the computation. What is the uniqueness of the computation? Here you can see when we have applied each input symbol on this state. That is the property of DFA. And when we are applying the input symbol on any state, it will reach only one state, not more than one. Okay? Now representation. First representation, transition state diagram. So what is transition state diagram? It is a graphical representation of finite automata. That is called transition state diagram. So a transition graph or transition system is a finite directed level graph in which each circle represents a state and directed edge indicate the transition of one state to another state. And the initial state represented by a circle with an arrow point towards it, that means incoming edge, and the final state by two concentric circles. And what is transition table? Transition table here, that is called transition table. First row, and the row will that first row means we will tell you that delta, sigma and k. That means when we are going to draw transition table, this block will say about q and sigma. That means column represents the states of set q. Column represents the state of set q, and sigma the rows. This row will represent about the input symbol of sigma. That means every block, let's assume we have in our sigma a and this is q0, q1 and q2. So this block will represent the state which are going to reach if we apply A on Q0. Okay? This block will represent if we apply B on Q0, then it will reach to a state. That state will represent. That is the transition table. And transition ID is the particular representation of this block. That means there is a transition function and we are going to apply A on Q0. That means we are going to write here Q0 and A. And let's assume it is going to reach to Q1. So if we apply on if we apply A on Q0, we are going to reach Q1. Okay, that is called transition ID. Is that clear? Now acceptance by DFA. Let W be a string designed from the alphabet sigma corresponding to W if there exists a transition for which it starts at the initial state and ends in any one of the final states. Then the string W is said to be accepted by the finite automata. We have given the previous, that means A, B, B. This is a collection of input symbols, that is a string, and if we apply this string on this DFA, then it is going to reach the final state. That means this string is accepted by the DFA. Mathematically, that is M means LM. M means particular, that is called membership function. Okay. LM means the languages of M. What is M? Here M is a machine, or you can say DFA. The languages of DFA is W belongs to sigma star. That means W can be the connection of sigma, and delta star is comma W. That means delta star is comma W belongs to A. Now, S means set of initial state, and if we apply W, W is a collection of input symbol on initial state, we are going to reach final state. Okay, so I think is that clear to you? So a language is said to be regular language if it can be accepted by a. Now, design a minimal DFA that accepts a language L where L of A over the alphabet sigma equal to A. That means initial state. If we apply A, then it's easy. Okay, so we have where A equal to A, where A is equal to language A and sigma is equal to A, sigma equal to A, that means there are no input symbol except A. So we don't have to apply any other input symbol except A. And we have to apply here. So on the final state, if we apply A, it will stay on the final state. Now design a minimal DFA that accepts all string over the alphabet sigma equal to A comma B, where every accepted string W starts with substring A is equal to B. So starts with substring A. So what will be the language? First we have to identify about the language. So where every accepted string W starts with substring A, where A is equal to B. That means every accepted string W starts with B. So minimum language would be B. Then it can be BA, it can be BB, it can be B, triple A, BB. Must start with B. Okay. Now, so we have to think about only minimum language. Okay. So Q0, if we apply B on the initial state, that will reach to the final state. Okay. Now, then think about, have we applied every input symbol on the initial state? No, we haven't applied it. Now we are going to apply A. So if we apply A on Q0, then That means if we apply A on Q0, that means it is going to start with A, but here every accelerated string W starts with B. So if the string starts with A, it will go to the reject string. Clear? Then, so here we have applied A and B, all input symbol. Then we are going to check about QF. If we apply B here, that means it is going to start with B, then QF means the final state. So when we are going to reach the final state, we have to start with B. We have started with B. Then after B, it can be any combination of A and B. Right? It can be any combination of A and B. So it will stay on the QF. That means we have started with B. After that, there can be any combination of A and B. It is a valid string. Okay. So what is invalid string? If it is started with A. So now we have applied A and B on QF. Okay. Now if we have applied A and B on reject state, it will stay on the reject state. Okay. That is the minimal DFA that accepts all string over the alphabet sigma equal to a comma b, where every accepted string double starts with substring s. Okay. So then what will be the transition table? So there are three states. Q0, Q1, QR, and QF. So if we apply A on Q0, it will go to QR. If we apply B on Q0, it will go to QF. If we apply A on QR, it will go to QR also. Same for Q1, same for B. And if we have applied A and B on Q, it will reach to QF. So that is the transition.